Hello my dear students, welcome to our channel. I'm Mr. Physics, where physics gets charts. In the last video we discussed the expression for electric field strength due to a dipole on its axial line and equatorial line and at certain angle. So now when this dipole of length 2a and dipole moment p is placed in the electric field at certain angle theta to the field direction, then it experiencing the torque. So we are going to derive the expression for torque on the dipole in the electric field, okay, in a different cases. So for this, here it is I am applying the uniform electric field in the plane of the board horizontally towards rightward. So in this I am taking a dipole of negative and positive charge AB which are separating the distance of 2a. So because of this, here when you are coming to the individual charges of plus q, this plus q charge will experience the force in the direction of electric field from basic property of the charge. So that here we can write the force on this positive charge F is a q into E bar is the force, and at the same time we also know that negative charge is experiencing the force in the direction of opposite to the direction of electric field. So as the electric field is towards right, so the force on this negative charge is towards left, and this force F bar is equals to again q E bar, but I am not writing minus q E bar here. This while we are writing the force on the charge at electric field strength, we should not be substitute the sign of the charge as we discussed previously. That's that sign is utilized to know the direction of force on it. So based on that, this negative charge is experiencing the force at leftward and the positive charge will experiencing the force rightward. So this is the dipole of system length 2a. So from rotational mechanics, when any system, when the two forces which are equal in magnitude but opposite in direction acting on a system at two different places along the line, so that which causes the rotation. When it causes the rotation, so in order to rotating the body, we need a physical quantity that is called torque. Means here that is what we are discussed, the torque acting on a dipole placed in the electric field. And from mechanics, rotational mechanics, torque is equals to, we know, force into perpendicular distance, force into perpendicular distance between those two forces. So here the force is a F bar, and a perpendicular distance between the two forces when you are joining the line along the two forces which are acting there. So that here it is, let this is the point C. So this is what gives the force acting on this. So for this, when you are supposing this is a theta, why? Because it is an angle theta. So we need BC only. So can I write a sine theta is equals to opposite side is a BC and hypotenuse is a AB. So here BC upon it is a 2a, which means we can write BC is equals to 2a sine theta. Means here from this is what the perpendicular distance between the two forces of F1 and F2 which are in opposite direction. One is the rightward, another is the leftward. So now the magnitude of this force is a q into E, and the magnitude of this perpendicular distance is 2a sine theta is the torque tau. So that here we can write q, and rearranging this 2a into terms of this equation E sine theta. So again the product of charge and the perpendicular distance between the two charges in a dipole is said to be dipole moment P. Therefore we can write tau is equals to P E sine theta. So this is what the expression for magnitude of the torque acting on a dipole. So here as it is a vector, so that in a vector form if you want to write this, tau bar is equals to P bar cross E bar. Why? Because from cross product of two vectors, A bar cross B bar is equals to AB sine theta. So as we have here P E sine theta, P is a vector quantity which is a dipole moment, and E is electric field is also a vector quantity. So we can write a tau bar is equals to P bar cross E bar. Here in this we can take the two cases. When the case 1, if theta is equals to 0 degrees, when theta is equal to 0 means this dipole is aligned in the direction of electric field. When it aligns in the direction of electric field like this, and on this the positive charge is towards rightward experiencing the force, and negative charge will experience the force towards left when the two forces acting along the same straight line opposite direction. Does that constitute the couple? No, because net force is 0 when the two forces acting along the same straight line like this. Does these two forces rotates this system? No. When this not rotates the system means from rotational mechanics net torque is 0. Like in the linear mechanics, if the net force on this body is 0, body does not displace. Like that in the rotational mechanics, if the net torque is 0, then body does not get rotate. That is the meaning of theta is equals to 0. Means it is aligned in the direction of electric field like this, so that this positive charge experiencing the force rightward, it is leftward. So when theta 0, sine 0 is a 0, P is sine 0. Of course mathematically it gives 0, but what is the significance of this theta 0? You have to know from the diagram, please, right? So there is no torque on the dipole when it is in the direction of field, or even if you are taking or 180 degrees, or 180 degrees means now the same dipole which I am previously placed like this, so now I am rotating like this. So even though I am rotating in this direction, of course it makes an angle theta 180 degrees, means negative charge is this side and the positive charge is this side. So dipole moment is towards left, electric field is towards right, so that what happens there? So that what happens, theta is a 180 degrees, or when you are placed it in this manner, it is supposed to be negative charge, here it is a positive charge, dipole moment is towards right, the electric field is also be towards right, so that theta 0. Understood the cases? Of course mathematically it is a very simple to substituting theta 0 or 180, torque is 0, then what is the significance here, sir? So when this is supposed to be negative, here it is supposed to be positive, so dipole moment is towards right, electric field is also be towards right, torque 0. When I am rotating the dipole like this, now the dipole moment is towards left, why? Because left negative to positive, and electric field is towards right, then also experiencing no torque here. And coming to the case 2, here, if theta is equals to 90 degrees, then which means here we are placing like this, dipole moment is upward, according to this is negative is a positive, then dipole moment is upwards, electric field is rightward, so then we can write tau is equals to P E sine 90, so that sine 90 is a 1 is a P, means the torque acting on a dipole is a maximum when theta is equals to 90 degrees, and torque is minimum when theta is either 0 or 180 degrees. So now we will take one special case. So in a uniform electric field, so here we can write F1 bar is equals to QE bar, and F2 bar is also QE bar. But when you are coming to the net force on the dipole, so we can write F net bar is equals to F1 bar minus F2 bar because of opposite in directions. So as these two are of same magnitude, QE bar minus QE bar, so the net force on the dipole when the dipole is placed in a uniform electric field is 0, but the net torque is not equals to 0. This point is important for examination point of view. This is the uniform electric field. So in the uniform electric field we can write a net force on the dipole is 0, but net torque is not equals to 0. Now I am coming to in non-uniform electric field. Non-uniform electric field means at a different locations the field have the different strengths, so that here we can write F1 is equals to QE1 and F2 is equals to QE2, so that the net force on this dipole is equals to QE1 minus QE2. QE1 minus QE2. Does it equals to 0 here? No. Why? Because when the field strengths are not same, of course the magnitude of charges are same, but because of difference in field strengths, as it is a non-uniform electric field, the net force is not equals to 0 in a non-uniform electric field, as well as the net torque is also not equals to 0. So maybe they are giving some different options in a uniform electric field and non-uniform electric field by changing these values. F net 0, tau net 0. Tau net not equals to 0, it is 0, or reversing. Like that 4 options are given based on this uniform electric field and non-uniform electric field. Got students? Thank you for watching. If you like my videos, do like, share, comment, subscribe my channel to get more videos.